All right, I'm recording. Example number 3, let's just read this out of the textbook, you guys. It says, use the data in table 2.2 on the preceding page to write a linear model for demand in boxes sold per week as a function of the price per box in dollars. So I don't know what the boxes are. They must be boxes of candy or something, but then it says describe the strength and direction of the linear correlation, then use the model to predict, oh, it's cereal, weekly cereal sales if the price dropped to $2 or was raised to $4 per box. So the data in the 2.2, I'm going to slide this back over here. Is right here. And I'm going to zoom in a little bit here. So that's the data, okay? It's the price per box versus the number of boxes sold. And so what I'm going to do is let's plot this. Let's plot this on a on our calculators, and then we're going to look at the correlation because that's really the best way to do this. And so if hey, that fit perfect. So I'm going to come in here and I'm going to hit list, edit, and I'm going to enter in 2.4, 2.6, 2.8, 3, 3.2. And while I'm doing this, why don't you guys get out your calculators, and I'd like for you to do the same. If you have it with you. If you don't have your calculator with you, that's okay. Just look up at the screen. But if you have your calculator with you, I want you to follow along. Okay. And let's come back up to the top. And we've got 3, 8, 3, 2, 1, 3, 3, 7, 1, 0. As I'm entering this in here, what I want you to do is look at the data, and what do you notice? Don't answer this question out loud, just think it in your head. What do you notice about the number of boxes sold with regards to the price? Is there a relationship between the price they charge per box and the number of boxes sold? Okay. Would anyone like to elaborate on that?
The higher the price, the less they sold.
Yeah, the higher the price, the less boxes they sold. That kind of makes sense, right? Everybody would love to buy a box of cereal at $2 a box, but when it starts to get closer to $4, it's kind of expensive. Or they don't buy as many boxes, right? All right, so now what I want to do is before I show the graph, I need to turn on my stat plot, and mine is turned off, so I'm going to hit turn that on, and then I'm going to change the window to zoom stat, which is option number 9, and there it is. Now what the textbook asks us to do is to determine about how, or kind of guesstimate how many boxes we would sell if the price was $2 and if the price was $4. And so how could I make those predictions? How could I make those predictions? What would you do? Because the lowest price is $2.40 and the highest price is $3.60. And they want us to make some sort of number prediction. How would you do that? This is why I want you to have your calculators out, because I want to show you this. What we need to do is we need to graph a line that goes through the center of these points with some degree of accuracy, because that looks like some sort of trend. This is what we call a negative correlation. Negative because the slope is in the negative direction, right? We're going down and over. Our rise is negative. correlation in the fact that the line, that the plotted points almost look like a line. They're not perfect, but it looks pretty close to a line. Now, in statistics, we'll show you how to do this by hand, but here in pre-calculus, what we're going to do is we're just going to let the calculator calculate this for us. So when we go to stat, if you click on the stat button, and you go to the calculate menu, we could do a linear regression, option number 4. Now, if I just hit enter, it'll find the best fitting linear equation to fit the data. But I want to graph the line too. So to graph the line, if I hit vars and I go to y vars and select function and select y sub 1, now my calculator will calculate a line of fit and store it in y sub 1. It'll graph it for me. So when I hit enter, this is my equation of the line, y equals ax plus b, where a is the slope, or negative 15,358. And my y-intercept is what? 73,622. So now when I go to y equals, it has that equation. I got a lot of decimal points in there, and you could change that in your menu, but that's the equation. So now when I hit graph, I have a line. Now how can I determine the price or the number of boxes sold based on the price? Simple. I just go to the table. $2 per box should sell about 42,905 boxes. Now, it's not perfect. It may be more, it may be less, but that's a good approximation. That's based on that line. At $4 a box, I'll only sell 12,000. Let's do some math. It's not part of the question, but I want you to think why this is important to a manufacturing company, people that sell cereal. At $2 a box, and I sell 42,000 boxes, how much money will I take in? Roughly $84,000, right? Now, at $4 a box, I'll sell 12,000 boxes, roughly. How much money will I take in? $48,000. So what does the company want to do? Well, they want to know, they want to find the right price, right? They might make a lot more profit, but they won't sell as many boxes. Do you understand why this is important? So all those years when they were teaching you how to graph a line and you were like, when am I going to use this in the real world? This is how we use it in the real world. So let's go back and look at our textbook. We were asked to kind of just create the model. We created the model and then we were asked to interpret that. And that's pretty much it.